Um, just to review how we do this now. So what you're doing, and you already know this, anytime that you do a derivative of a sum, you can do the derivative of each part. And you don't have to write this down. I mean, we already did this problem, but you're going to do this in your head anyway. All right. So the thing is that we are trying to make sure that we were grasping is the variables are the same. So we're doing d dx of an expression with a variable x. So that's what you've been doing all semester. So we said, okay, the variables agree. So now that just means we would use like kind of your basic derivative rules that you've learned like that, and you can just do this in your head. Okay, so this problem's real easy. Just do it in your head. What's the derivative of e to the x? E to the x. Well, all right. And what's the derivative of 3ln x? 3 times 1 over x, so it's 3 over x. Okay, just do it in your head. And that's the kind of thing you've been doing all semester. Okay, so now what we're doing is kind of looking at a situation where the variables are different. You're doing d dx, but the variable's y, so we would say these variables disagree. And when you do that, you really use the chain rule. And I don't know that you really need to be totally on top of why it's the chain rule. What I was trying to say is when you differentiate a different variable, just make sure you tack on times dy over dx. Okay, that's the chain rule where it comes from. So if you do this, that would be a power rule. So you'd bring down the -5, you would subtract 1 from the exponent, which you can do in your head, but you have to tack on that dy over dx, okay? So you could write this derivative just as -5y to the -6 times dy over dx. You could change that negative exponent to positive also if you needed to, okay? So that's it. That's what happens when the variables disagree, okay? Yes? E to what? Like e to the third? Okay, that is 0. And the reason for that is because there's no variable. That's a constant. So e is about 2.7. You take 2.7 to the third, you just get a number. So its derivative is 0. Okay? All right, now this next one, I think we did an example like this. What you have to understand on this one is there's 2 different variables. So and they're multiplied. So you're really what you have is you've got a product rule situation right here. Okay, the first is going to be x squared. The second is going to be square root of y. So what I would suggest we do is, since we're going to have to do the derivative of both of these terms, I would suggest that we write this as x squared times y to the 1/2 like that. Okay. Now, I'm going to write down the product rule just in symbols. You don't have to if you don't want to, but this is what we're going to be doing, is just putting that in the product rule. Okay, and you can do this in your head. I'm going to do just kind of write down, putting it in the product rule first. Okay, so when I do this, I'm going to write down the first. I'm going to do the derivative with respect to x of y to the 1/2, which you're more than welcome to do that in your head if you're good with that. Okay, then plus the second, which is y to the 1/2, and then times the derivative with respect to x of the first x squared. So I think when you're learning how to do this, it's worth just putting it in the formula first. Okay, all right. Now the rest of this you'll do in your head. You got 2 derivatives to do, and these are easy enough that you could do in your head. Okay, so the x squared comes down. All right, do the variables agree or disagree on that term? Disagree. What does that tell you you're going to have to do? You have to have that dy over dx in there. Okay, you do normal differentiation. That's a power rule, so that's 1/2 y to the 1/2 minus 1, which you can do in your head. That's -1/2, but then tack on the dy over dx like that. Okay, that's what you have to pay attention to. Okay, now you go to the next part. The y to the 1/2 comes down, and the variables agree on the last term. So what's that derivative? 2x. There is no dy over dx there because the variables agree. Okay, and that's good enough. We don't need to simplify that or anything. That's fine right there. You've done what I wanted to show you needed to do. Okay, Now you could, I'll just go ahead and show you a couple other things on this. You could write this as x squared over 2, and then you could move that to the bottom, making that a y to the 1/2, and then that'd be a square root of y. So you don't have to do that unless I'm really directing you to do that. But that's kind of what we're used to doing. Then times dy over dx. And then this, it doesn't matter what order you put these numbers in. It's generally preferred to put stuff in alphabetical order. Okay, you don't have to. I wouldn't count that against you if you didn't do that. But that's just sort of the preference, that way you're always going to see that written. Okay? All right, so that's product rule. Does everybody understand how that went okay? Okay, and when to use dy over dx. Okay, now you can also do this. I mentioned this last time. If you would prefer to be a y prime guy, okay, you could write that as y prime. I'm always going to do dy over dx, and the reason I am is because of related rates problems that we'll probably start looking at a little bit second half of class today. Okay. All right. Next one. Okay. This one is like a chain rule. This is like an extended power rule. Anytime we have parentheses and a power, we brought the power down, subtracted 1 from the exponent, multiplied by the derivative of what's inside. So we worked on this kind of problem quite a bit last time. Okay, so this is going to go like that. Go ahead and bring your 3 down. Leave the part in parentheses alone, and then that's to the second power. Okay, but you have to multiply by the derivative of what's inside. Okay, so I'm going to just kind of put that in your chain rule like that. Okay, so that's how you have to start the problem. The rest of this problem, you're probably just going to do totally in your head. Okay, so when you bring this down, you've got 3x plus y to the second squared. And then see if you can process this in your head. What's the derivative of x? The variables agree, so what is that? 1. How about y squared? The variables disagree, so what's that? 2y times dy over dx. Good. Okay, so you just do it in your head. And then that's all we're going to do on the problem. There isn't anything else we need to do on the problem. That's your derivative. Okay, so you're doing all of the type of differentiation that you've learned how to do. It's just when the variables disagree, out pops that dy over dx. And you'll see why here in a minute. Okay, I'm just preparing you for the implicit differentiation that we're going to learn today. All right, any questions? Anybody has? Okay, all right. Okay, so next page, this is where we're going to learn how to do it, okay? We're going to learn how to put this all together. And you have to learn how to do this for the next section that I'll start teaching today. And there will be some business and economics examples. We probably won't get to that today, but we'll be focusing a lot on the business stuff next week. All right, so there's really 2 key steps. There's really, you differentiate both sides with respect to x, and then you solve for dy over dx. That's step 2 and 3. Sometimes you have to do those. But the key thing is, if I want you to do implicit differentiation, first of all, you do not solve this equation for y. You just leave it the way it is. We talked about that last time. That's an implicit form. If it's not solved for y, it's implicit. So we go ahead and do the derivative, all right? So here's the 2 key steps. And just kind of write down as we go through this. Step 1, you want to really just put a parenthesis around each side of the equation. And then you want to take the derivative with respect to x. The reason that you're doing that is because I want you to find dy over dx. If I wanted you to find dy over dt, then you would do dt of both sides, okay? And again, most of these problems are going to be easy enough derivative-wise that you'll manage in your head fine, okay? You should anyway, okay? All right, so what's the derivative of y squared? I heard a bunch of mumbling after that. dy over dx, is that what I heard a bunch of people saying? Okay, because the variables don't match, right? Okay, you got to be careful with that, okay? What's the derivative of 3x? Do you need a dy over dx? No, the variables match, okay? What's the derivative of 8? 0, there we go. That's step 1 right there. So you always do the derivative of both sides. Now, what's always going to pop up? It will always pop up. A dy over dx will pop up. It may pop up once. It may pop up 2 or 3 times. Okay. So what we do in step 2 is now it's algebra. So step 2, what we're going to do is solve this equation for dy over dx. A lot of times you'll do this 100% in your head without having to show any steps. Okay. So really what you're doing here is you're isolating this by itself. So what do? It's just like solving an equation. You get rid of 3, right? You subtract 3 from both sides. And you can do that in your head. You don't have to write that step. So you do that, and then that's going to give you 2y times dy over dx equals -3. Okay? So it's just like solving an equation. So how do I get rid of 2y? I divide by it, okay? I divide because it's multiplied. So I need to divide both sides by 2y. And then I've got the result of the derivative, which is going to look a little different than what you're used to looking at. So we get dy over dx equals -3 over 2y. That's your derivative, and it happens to have y in the answer, okay? Which is very common. Typically it will, all right? So what you're doing is you're doing a derivative without being forced to solve the equation for y. And it's a 2-step process that you do. Do we have any question on that? Okay, that's probably pretty simple. We're going to kind of start simple on this. Okay, now the rest of the problem will kind of help you hopefully make sense of this. It says find the slope of the tangent line to the curve at the point 1√5. So the way I like to write this step is the slope of a tangent line is the derivative evaluated at 1 square root of 5. Okay, and what you're going to do is you're just going to plug in to the derivative we already got. Now this is x. There's no x to plug into, but there is a y, so that y is going to plug in right there. So you're going to have -3 over 2 times square root of 5. That's the slope of the tangent line. Okay, so you get that derivative implicitly, and then I always give you a point on these problems. I'm never on these problems going to give you just x and you have to find y. I'm not doing it that way, so I give you an actual point on there. Okay, does that make sense? Okay, I didn't have to do anything with the x value of 1 because there was no x in the derivative. So don't let that bother you. That makes it simpler, okay? Okay, next thing we want to do is we're going to do something on the calculator. So write down the function that we're working with. We got y squared plus 3x equals 8. Now we're going to solve this for y. And I think we went over this last time. So if you're going to get y by itself, what do you do to both sides? Thank you. -3x. Okay. So we got that. That'll give me y squared equals 8 minus 3x. Okay. But next, square root both sides. When you square root both sides, what do you have to remember to put in front of the radical? Plus minus. Good. Okay. All right. Okay. So we have y equals plus or minus the square root of 8 minus 3x. Okay, now we're going to go to our calculator, and I'll show you what I want you to put in your calculator. Okay, so get out your calculator, and we have to put this in 2 steps. You have to put the plus in and the minus in. So when you go to y1, you want to go square root of 8 minus 3x. And what that's going to do is only going to give you part of the curve. It's not going to give you the whole curve. Okay, so we do that. We go down to y2. Now put the negative in. Don't put the subtraction symbol. Make sure you go to the bottom and put that negative in. And then you do same thing, square root of 8 minus 3x like that. Okay, and we'll just do this in a standard window and kind of take a look at this. So zoom 6. And what's going to happen is you get this. Now, is that a function? No. Why is it not a function? Vertical line test fails, okay? So a lot of times when you're dealing with implicit differentiation, you're dealing with things that are not functions, okay? So that's kind of what the idea is going to be is, and I don't think in college algebra you learn much about what we call conic sections anymore. Did you guys learn about ellipses Hyperbolas, anything like that? Like barely like the last day of the semester or something? Okay, yeah. So like that, this is actually a parabola, but it's sideways. Okay, I mean that's what that is. Usually people don't learn a lot about conics much anymore unless they're in calculus 3, which I don't think anybody's going there, right? Okay, all right, you might change your mind, who knows? Okay, all right, let's go to the next page then, and I'm going to write down, we had two things. We had the point that I gave you in the problem was 1 square root of 5. Okay, and then the slope of the tangent line, we got that. That was -3 over 2 root 5. Okay, so we got all the information we need to find the equation of the tangent line now. So again, that formula, just write down the formula, which is y, whoops, that's not it, y minus y1 is equal to m times x minus x1. Okay, now we're just going to plug everything in. We got everything we need, so let's see. We got x is 1. That was given in the problem. Y1 is square root of 5. That was given in the problem. And then we found m by using implicit differentiation. So that's going to go like that. Okay, so we're going to do this, and then we're going to graph it. I'll kind of show you how the graph goes and everything on the calculator here as well. Okay, so we have y minus square root of 5 equals -3 over 2 times square root of 5 times x minus 1. And you don't want to change those square roots to decimals. There's no need to do that at all. Just leave it alone. Okay, so what I'm going to do is I'm going to do a distributive property here. So that part would be -3 over 2 root 5 times x. Okay, that takes care of that. Then we would have this way, this one you got two negatives, you have a negative times a negative, and you're just multiplying by 1, so that'll be +3 over 2 root 5 like that. Okay, now the only other thing you got to do on this is you got to add square root of 5 to both sides, which you can do in your head. You don't have to really show that all the time. All that really does is it moves the square root of 5 to the other side of the equation. And it changes from negative root 5 to positive root 5. So the equation of this tangent line, and we're not going to take this any further, we'll just write it as y equals -3 over 2 root 5 times x plus 3 over 2 root 5 plus root 5. That looks like kind of a weird answer compared to what we've been seeing with tangent lines, but that's what it is. Okay, so what if you have radicals? Okay, that's the way that you'd want to write that. So again, that part right there is things we've been doing, and we've done that a lot this semester, working with tangent lines, because that's what a derivative does. It gives you an equation of a tangent line, it gives you a slope of a tangent line. Okay, now what I want you to do on your calculator now, you don't need to graph this. I think, did I give this graph to you guys? Is that on your handout? Okay, that's what I thought I intended to do. So just do this. Now watch how I type this in. The thing is, when you type in that -3 over 2 root 5, you have to type it like this. You have to say -3 divided by parentheses 2 times square root of 5. And the reason you got to do that is actually the calculator needs to do the denominator before it divides the -3 by it. So if you don't put it there, it ain't going to do the right thing. Now you can put in your x, okay, like that. Then the rest of it, you're going to have to go like this. You go 3 divided by, and again, I'm going to do the same thing, 2 root 5. It should work if you don't do that on that, but just to develop the habit, you know, the general rule of thumb, if you have fractions, numerator and denominator, if you always put the numerator and denominator in parentheses, you'll never go wrong. Okay, so we got that. Then we have plus square root of 5 like that. Okay, now once you get that put in, then just type enter, and let's see if it gives kind of what I had given you on there anyway. Okay. Oh my God. Okay, I'm glad that happened today, though. You could tell that is a wrong tangent line, right? What in the world? I either put something in wrong, Or, what in the world did I do wrong? Okay, I think we have to go like this. Okay, let me show you something that's easier. Okay, actually, it's easier if we do it this way. Um, Now, you don't need to erase what you did because we have a right answer to the tangent line. But actually, it would be a lot easier if we typed it in the calculator like this. I think you understand this way better. So we would have y equals, and then I've got -3 over 2 root 5, parentheses x minus 1, plus square root of 5. Okay, you could write the answer that way too. Okay, you don't have to distribute that slope through x, but you'll probably, I think I'm missing a parenthesis is what I'm doing. Probably that entire thing that's in front of x needs to be in one big set of parentheses. That's what's going wrong here. So let's just put it in like this. So do it like this. You'll have parentheses -3 divided by another set of parentheses. This is what I did wrong. 2 root 5. Okay, times x. Okay, and I got to close that parenthesis times x. So I'll go like that. Whoops, I got to do new parenthesis like this. I got to go put a left parenthesis there. Nope, 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 like that. Then I got to do the open parenthesis x minus 1 like that. And then plus the square root of 5. If that's difficult for you, then my recommendation is just take your calculator and work out -3 over 2 root 5 and change it to a decimal. You might do it better that way. Okay, so now if I put this in, let's see if that's better now. There we go. Okay, so that's it. So it's basically touching that point. If you traced at the point 1, what that is, this point right here on the calculator is 1, and that's square root of 5. That 2.23 is square root of 5. So that's right. Okay, so you have to kind of be careful about how you put stuff in. Ultimately, what I needed to do was write this kind of as -3 over 2, parentheses 2 root 5, like that. That's how that has to be put in. Okay, because if you don't put it in like that, it just calculates it wrong. Okay. All right, any questions about what I did? Okay. All right, I think we'll do kind of work with another example. Then I am going to have you do 2 problems to finish up the section. So let's go down to this example 4 and kind of see what we're getting into here. Okay, so again, it's a 2-step process primarily. So your first step is you just want to put parentheses around the problem, around both sides. And we're going to do the derivative with respect to x of both sides like this. Okay, this problem is probably, this one and the last problem that I'm going to have you do to complete the section are probably as advanced as it will get in this class. My Calc 1 class is a little bit more advanced than this. Okay, so let's do this. What's the derivative of y squared with respect to x? 2y times dy over dx. Everybody understand why I'm doing dy over dx? Variables disagree. Okay, how do you think I'm going to do the derivative of xy? Product rule, product rule. You have to. A lot of times students do not see that. That is 2 different functions. It's 2 different variables multiplied. So that thing right there is going to be a product rule, okay? All right, so when we do that, remember the product rule, you do the first x times the derivative of the second, which you can do in your head, but I'm going to write it down like this first. Then you write down the second multiplied by the derivative of first. So that piece right there, again, is the product rule. Okay? All right, now the derivative of 3x, what is that? 3, there's no dy over dx. And finally, what's the derivative of 9? That's the easiest part. That's 0. Okay, so there we go. All right, now And I think I missed, that's supposed to be d dx of x, okay, when I do that. All right, so let's kind of see what we got now. So I'm going to bring all this down. I've got 2y times dy over dx, and then I've got plus x. Now this will pop up a lot. I'm going to kind of talk about this at the side of the paper. Okay, you can do this in your head. There's nothing to it. The derivative of y is 1, right? If the number in front of y is 1, but the variables don't match, so it's dy over dx. So it's just dy over dx. So when that pops up, all you got to do is, when you do a derivative of y with respect to x, that's what dy over dx is anyway. So you don't have to show that step that I did on the side. Okay, then over here we got y, and then the derivative of x with respect to x is 1. No derivative of x is 1. Variables match, so no dy over dx there. Okay, so that's step 1 of the problem right there. All right, it's a little harder because it's got the product rule embedded in it. That's what makes that a little bit more difficult for students. Okay, when we go to step 2, what we always do in step 2 is we try to solve this equation for dy over dx. Okay? All right, now here's the way you want to look at this. All right, you want the dy over dx's to all be on the same side of the equation. If they were on different sides of the equation, you would want to move one of them so they're together. So everything that has a dy over dx needs to be together, and everything that does not have a dy over dx, which is these two things, needs to go to the other side. Okay, because we're going to solve this for dy over dx. Okay, so that's a real important part of this problem. Okay, so what we're going to do is write this as 2y times dy over dx plus x times dy over dx. And if you're not used to this, you know, I always, if I teach college algebra, try to get students used to doing equations in their head. Just move this stuff, and it doesn't matter what order. You're subtracting 3, so that will be a negative 3. That's a y. When you move that to that side, that's a minus y. And it doesn't matter what order that's in. If you put minus y minus 3, it's the same thing. Okay, so that's up to you. Okay. Now, what you have to do is you have to factor. Okay, anytime that dy over dx shows up 2 or more times, you have to factor it out. Okay, so watch how I do this piece right here. You factor that out, which you can do in your head. So you'd have dy over dx. If it's helpful to you, just kind of imagine those things going away. What would you be left with? 2y plus x, right? Okay, so you got 2y plus x is equal to negative 3 minus y, like that. Okay, is that making sense? Okay, now what do I do? Got one more step and I'm done. You got to divide by the thing that's being multiplied, right? So you need to go through and divide both sides. 2y plus x, 2y plus x, and then you've got your answer. So your derivative on this, dy over dx, our answer is negative 3 minus y over 2y plus x. Okay, that's a little bit more advanced problems than the one I've done, just because it's factoring. That will make it a tad bit more difficult. All right, because you're going to do a problem like this in a minute. So does anybody have a question about what I did? Okay, I'll find out soon how good you can do this, and I know you can do it well. All right, now, next thing I do is we're going to do the slope of the tangent line at the point 2,1. Okay, so the way that I was showing you to represent that is just write that as dy over dx bar 2,1. That's just kind of the language of how you do that. All right, what do I need to do with the 2,1? Plug stuff in, right? Okay, 2 is x. Sometimes can't write on this thing. So 2 is x. 2 is x, and then, of course, 1 is y. So just plug it in. So you're going to have negative 3 minus 1, and then 2 times 1 plus 2, like that. Okay, so just plug x and y in, and then do your calculation. So that'll give you your answer. Sorry, I'm getting choked up. Okay, so that'll give negative 1 should be your answer then. Okay? Okay, any questions on that? Okay, so I'm going to give you some time to work the last two problems on this handout. And just kind of work together, compare your answers. I'll come around, see how you're doing. I think the first one on the next page, you're going to do the graphing and everything because that'll help you understand the problem, I think, better. And then the second one is kind of like this one, just kind of doing the derivative and see if you can handle the factoring and all that kind of stuff like that, okay? So I'll leave that up there and start working on them, and I'll come around and see how you're doing. Okay, so with this one, again, you're doing the derivative of both sides of the equation. Okay, so you have to know your derivative rules. You have an exponential. You also have a logarithm in here. Okay, so it goes like this. Okay, and I think for the most part, we're doing pretty well the first step. That derivative's 2x. Derivative of 2x is 2. And then e to the y, the derivative of e to the y is itself. The variables don't match. So what do? You put your dy over dx. So you'd have to have that. Okay, on this side, you have the constant 4. We know the derivative of ln y is 1 over y. Again, the variables don't match. So we have dy over dx. That's the first thing you got to have on your paper. All right. All right, now there's a few of you don't have all of your rules memorized, and you just got to work on that and get all this memorized so you don't have to look things up. Okay, now the way I would do the problem, it's up to you which side the dy over dx's need to be on. You can get both dy over dx's on the left, you can get on the right. I always do which way is easier. To me, it's easier to move this over there. So I'm subtracting that e to the y dy over dx. So I've got 2x minus 2 equals, and you can write this as 4 over y times dy over dx minus, that sign changes, so that's e to the y times dy over dx like that. Okay, that's the way I would do it. But if you wanted to move that to the other side, the left side, you're going to get the right answer. So I've got 2x minus 2. I factor out the dy over dx. Okay, when you factor it out, you're going to have 4 over y minus e to the y like that. And then one more step and you're done. Okay, what's the last step? Divide, exactly. Divide by what you're trying to get rid of. That's being multiplied. So if you divide both sides by 4 over y minus e to the y, then you got it. Okay? So and I wrote the other possible answer on the board. If you did dy over dx on the other side, it would have worked out probably like this. 2 minus 2x over e to the y minus 4 over y. That's the same answer. Because if you subtract backwards, it's going to be off by a negative. So if they're both backwards, it kind of balances everything out. Okay? Yeah. Sure. Sure. I mean, you can write it as 4 to the negative 1. That's your call. That doesn't matter. Okay. All right. Do we have any questions? Okay. Good job. Let's go ahead and break here till 1:10. I'll pass out your written assignment 4 that you turned in Tuesday while you're on break, and then the new notes. Okay.